Welcome back class. As you know that chapter number 3 is running now, which is the part of the electrodynamics, and in this chapter, today's topic is electrical cell. So one small introduction you already discussed in the class 10th, and today I am also giving you some brief introduction regarding the electric cell. So in this topic we will discuss about what is the electric cell, what is the function, and how you can connect the cell in the series combination and the parallel combination, and also the concept of the internal resistance. Right now, what is the internal resistance? What is the meaning of the internal resistance, and why this internal resistance produced in a cell? So let's start the topic. So today's topic is electric cell. Right now, electric cell. So you know that in any circuitry, the electric cell is providing the potential difference, and because of this potential difference, the current is circulating, or the charge is circulating through the whole circuit. So you know that this is the negative plate and this is the positive plate. The smaller plate is the negative plate, and the bigger plate, which is the symbol is the positive plate. So before starting off what is the electrical cell, I am giving you some brief introduction regarding to the what is the actual functioning of the electric cell. Unless you understand what is the functioning of the electric cell, it is very difficult to understand what is the concept of the internal resistance. So first of all, what is the majority of students have the doubt regarding to the functioning of the cell. They are thinking this kind of cell has two plates, right? Cell has two plates, and here some chemicals are poured, and because of this chemically process, this plate is negatively rich, right? And this plate become deficiency of the electron. So by anyhow, this particular one plate is the negatively charged, that means the excess of electron is there, and this one plate is the positively charged, that means the deficiency of the electron is there. And they are thinking, because of this charge possessed by each plate, if you connect this by any wire, resistive wire, then because of the excess of electron is here, that is why they are start to move from this side, negative plate, to the positive plate, right? And because of this charge, as the electron reaches to the positive plate, the strength of the negativity or the strength of the positivity decrease. That means, in other words, in the simple words, they are thinking, because of the diffusion process, because we have the two plates, one is the excess of electron, one is the deficiency of electron, and when you connect with the proper channel, then the higher concentration of the electron at the negative plate will reach to the positive plate, and once all the electron will reach to this positive plate, then your cell get discharged. So they are thinking this is the diffusion process, but actually the process of the cell is different. It is not a diffusion process, and you can also predict very easily if the process of or the functioning of the cell is a diffusion process. So if you connect these two plates, with a proper channel, within a second the cell gets discharged. Within the cell, all the excess electron will reach to this positive plate, and both the plate get neutral. Already you understand the capacitor chapter. You are putting the charge from one plate and the negative plate. If you connect directly, within the second, the whole plate gets neutral. Right? So it is a diffusion process. But the functioning of the cell is not a diffusion process. So what is the cell? Cell is basically some chemical process happening here, the chemical reaction happening here, and because of this chemical reaction, the potential difference across the terminals of the cell maintain this positivity and the negativity maintain because of this chemical process. So what is the cell? The basic definition of the cell is a device which is maintaining the potential difference across its plate. Right now, so electric cell is basically an energy source which is maintaining the potential difference across the terminals of the cell. That is why the continuous flow of the charge is happening there, right now. And also that is why the current is not reducing if the electron is reaching from this side and reaches to the positive plate. So the charges are reducing. The charges are reducing. That means Q is equal to C to V. That means if the charge will reduce, that means the potential of the plate is reduced. If the potential across the plate is reducing, that means automatically the current will reduced according to Ohm's law, right now. For a given resistance, if the V will decrease, automatically the value of the current is also decreased. So if you are thinking the diffusion process, the electron is reaching from the negative plate and reaches towards the positive plate, so the electron decreased in the negative plate. So if the electron decreased, automatically the potential difference is decreased, right? So it is not happening. So what is the functioning of the cells? Anyhow, because of any chemical process, in the chemistry, I think there is a chapter in the chemistry class 12, electrochemistry, where you will discuss briefly what is the functioning of the primary cell and the secondary cell, where you will get the more clarification. Here only, because of any chemical process, the potential difference maintain across the terminals of the cell, and because of the constant potential difference across the plate, the constant current is flowing through the resistance. And also the question is, if it is not diffusion process, then how the cell get discharged? You know that because of the heating effect of the current, the electrical energy is transforming into the heat energy. So your cell get discharged because of the transformation or the conversion of the electrical energy into the heat energy. So because of that, heat energy which is liberated from the bulb is not returned back to the cell. That is why your cell get discharged, right now. And that is why it takes time, because not within a very small time all the electrical energy transform into the heat energy, right now. So this is your main functioning of the cell. So cell is a device which is the maintaining the potential difference across the electrodes, or you can say the terminals of the cell. Now another term is the electromotive force. Electromotive force. Electromotive force, right now? Electromotive force. So to understand the electromotive force, we just see the small circuitry here. There is a resistance R is connected across a cell, which is whose potential difference across the electrode is V. And if you are connecting the voltmeter across this resistor, you will get the reading which is equal to this the applied voltage of the cell. But if you just compare, so this is because the cell and the resistor is connected in the parallel combination. That is why whatever the potential supplied by the cell, it is coming across the resistor, and that is why the voltmeter is indicating the same. But if you measure what is the potential difference across the electrodes of the cell with the help of some other device which is called the potentiometer, then you will find this applied voltage, which is the V, is lesser from the value calculated from the potentiometer. So why this value is coming lesser? A few students are getting, sir, what is the potentiometer? So potentiometer is a device which will come in the forthcoming classes. This is also the part of this unit, but we will discuss later because it is the last topic of this unit. So currently it is a device which is measure the potential difference across the electrodes of a cell. So with the help of, when you are calculating with the help of potentiometer, you are finding this the potential difference across the electrode of the cell is more as compared to if you are measuring with the voltmeter. So why this difference is coming after if you see the microscopic view of this, why this difference is coming, it is found the methodology to calculate the potential difference across the cell is in the potentiometer is when you are measuring the potential difference across the electrode of the cell with the help of potentiometer. In that case, there is no current flowing through inside the cell. Right? There is no current flowing through the cell arm or the inside the cell. There is no ions are moving. But when you are measuring with the voltmeter, the current, you know that the electron is leaving the negative plate and reaching to the positive plate, and also some ions are moving inside the cell. So here when you are measuring with the voltmeter, the charges are circulating throughout the whole circuit, including the cell. Inside the cell also the ions are moving, right now. But when you are measuring with the potentiometer, the cell arm, I will discuss this one later. In the cell arm, there is no current, there is no ions are moving. That is why this difference is coming. So the concept of the electromotive force. The electromotive force is the maximum energy. It is the maximum energy supplied by the cell. Right? Maximum energy. When you are measuring with the help of voltmeter, you are finding it is not indicating the maximum energy of the cell. So what is the definition given in the book? What is the electromotive force? Electromotive force is the amount of work done by the cell to circulate a unit positive charge throughout the cell, including inside the cell. Right? That means throughout the whole circuit. The word is used whole circuit. Whole circuit. Whole circuit. Whole circuit means also inside the cell. Right now, not only the outer part of the cell, from negative plate the electron is moving, and also the reaching to positive plate. Not here the outer circuitry, also inside the cell. Here. So the definition of the potential difference and the electromotive force is similar, but only the word is here the whole circuit. The whole circuit means also the inside the cell. Right? Inside the cell. Or in simple words, I have given the basic definition. The electromotive force is the maximum energy or the total energy supplied by the cell. Right now, it is the total energy of this cell, which purchased by this cell. Right now, this is your electromotive force. And so, also don't be confused. The electromotive force, the unit of the electromotive force is not a Newton, right? It is why it is called force, because of some historical reason. They start historical reason they have named this electromotive force. But the unit of the electromotive force or the EMF is volt, not Newton, right? So, and because of they are thinking the electromotive force, it is the maximum energy, or which is responsible, a force, that force is responsible to circulate the charge. So this kind of historical explanation or the reason in that time, that is why they have given the name electromotive force. Right? So you understand what is the electromotive force? It is the maximum energy supplied by the cell. Right? And the definition given in the book, it is the amount of work done to circulate the unit positive charge throughout the whole circuit. Right? Whole circuit, including cell. Inside the cell also, right? So this is your EMF. But the question is, so that means the whatever that is indicated by this voltmeter is not the maximum energy. So where this energy, why this difference is there? When you are measuring with the potentiometer and when you are measuring with the voltmeter, why this difference is coming? So the difference is coming because of some amount of the energy get lost inside the cell, right? Inside the cell, some of the energy get lost. Why get lost? See here. Suppose this is the cell and these are the electrodes, and here the electrolytes are there. And if you are connecting here any electrical, any resistive wire, simply there is circulation of the charge is started. Now see. Because of when you are connected with the proper channel, the charges are start to flow. See, because when the charges are flowing through the conductors, you know that the conductors are allowing the easiness of the flow of the water. Flow of the charge. So still the conductors are the good path for to move the charge, but still they are opposing the flow of charge. They are applying some resistance. And although it is a good conductor of the electricity, but still they are applying some resistance. So inside the cell, you know that the ions are moving. Right now, if the electrolyte is the H2SO4, you know that the H plus and the SO4 minus. These are the ions. These are the ions are because of the chemical process they are ions are generating and they are depositing in the different electrodes. So that means inside the cell the ions are moving. And just compare the size of the ion. This is the electron and these are the, suppose this SO4 minus minus. If you just compare the size of or the bulkiness of the ions, this electron very small and SO4 minus very bulky. Not only the masses are more, also you can see here the charges is more. Right? So if the very small size electron experience the movement inertia and they are experience opposing effect, so this particular heavy ions are when they are moving inside the cell or in the electrolytes, then whether they will not experience some opposing effect? Surely they will experience the opposing effect because of the bulkiness. Right? So because of this movement of this bulky ions inside the cell, they are experiencing also the opposing effect. So because of that opposing effect, some amount of the energy or some part of the energy get elapsed. Clear? So because of this ion movement inside the cell, some part of the energy get lost, and this energy is lost is because of, they are saying, because of the internal resistance offered by the cell. Right now? So what is the concept of the internal resistance? Because the ions are moving inside the cell, that is why they are also experiencing the opposing effect, and because of this opposing effect, some energy of the cell get lost, and that energy is lost because of the internal resistance offered by the cell. Right now? So that is why a cell is representing like this. Right now? So if a cell is not an ideal cell, then you will show the cell like this one, and the cell and with a small resistance, internal resistance R. Right now? So also this resistance is not outside of the cell, but it is a symbolic representation. Whatever the resistance offered by the internally by the cell, we are simply with the help of with just adjacent of the cell, you just represented by the a small resistance. Right now? So this is your practical cell. Right now? Whenever you are seeing the ideal cell, then ideal cell has the zero EMF, zero internal resistance. Right now? Zero internal resistance. That is why the EMF is basically your potential difference. Right now? So here, so let's summarize what is the concept of the EMF. EMF is the maximum energy which is supplied by the cell. But practically when you calculate it with the help of the voltmeter, it is found some amount of the energy is elapsed due to the movements of the ion inside the cell. So this internal opposing effect is called the internal resistance, and because of this internal resistance, the energy get lost. So when you represent a practical circuit, practical simple circuit. So what is the structure? So here we have a cell, and this cell negative terminal you represent the internal resistance. So this is your cell. Right now? So here the negative plate and a positive plate, and along with the cell you will represent a small resistance which is the internal resistance. Right now? I am repeating again, this is not the outside the cell, but it is a symbolic representation. Whatever the resistance offered inside the cell, we are representing by the resistance, and which is just outside this cell. And suppose we are connecting with the external resistance R. We are connecting this cell with the external resistance R. And if you connect with voltmeter, so you will get some reading from this voltmeter. Now the C, because of this connection, the I current will flows. Current will flows in this circuit. So I am saying this is the R and this is the E. Right? EMF, I am representing the EMF is E. So if you see here, this small r, which is the internal resistance, and this capital R, both are connected in the series combination. It is a single wire. So this R and small r is connected in the series combination. So whatever the energy supplied by the cell, it is distributed into two resistors. One is through this resistor R, and one is resistor is internal resistance small r. So if you write the expression, so here the EMF, the total voltage is equals to how much? I into R plus I into small r. According to law of conservation of energy, or the property of the series combination, whatever the potential difference supplied by the cell is going to be distributed over two resistors, because in the circuitry we have the two resistors R and the small r. So this is equal to IR plus IR, right? And this IR, that means the current flowing through this external resistance R, and the value of the resistance is measured by the voltmeter. Right? If you connect the voltmeter across this resistor, so what reading is indicating? This I into R. So we can write this is the external or the terminal voltage, which is called the terminal voltage. So E is equal to V plus I into small. So this is the relation. This is the relation with the, this is called the EMF of the cell. EMF of the cell. This V is called what? It is called the terminal potential. And this is small r is what? The internal resistance. Internal resistance. Clear? So this is the expression which is relating the EMF and the terminal voltage and the internal resistance. Right? So you can see here this I into R factor. This fraction part of the energy is elapsed in the form of the loss due to the inside the cell. Due to inside the cell, this amount of the energy is lost. That is why it is not coming in the with the help of potentiometer. Right? So